Okay, so this is actually, I wasn't here on the day that they talked about this in class, so. But I know that we used some formula of B, which I guess.
Yeah, so the equation that we're eventually gonna end up using looks like this.
Equals 10 log I for I.
Good.
Or intensity final over intensity initial. Is that it?
Yep, so it's actually like intensity over intensity threshold. So I naught is typically this value, it's a constant. I naught is 1 times 10 to the negative 12.
Okay.
And that's going to be in units of watts per meter squared. And so I say that's our threshold because that's the lowest intensity that human ears on average process.
Oh, okay, cool.
So it's usually, this is the intensity that's actually happening. This is the lowest intensity possible.
This is yours.
It's not. And then you take the log of that, times it by 10, and then you get decibels, which you've probably heard, you know, people referring to sound as, oh, it's 100 decibels or whatever.
Okay, yeah, a little bit.
So this is the equation that we use to figure that out. We say, okay, the sound is making this intensity, we know that this is our threshold, we can use that to figure out how many decibels we're looking at.
Okay.
So in this question, we've got a firework going off. Obviously, it's creating sound. That sound has some power associated to it.
Okay.
And we know that we've got two observers. We've got one who's directly below the firework, and it said that was 105 meters, or do you have a different number?
Yeah, the height is 80 meters.
Oh, is it 80?
Yeah.
So 80 meters. And then we've got another observer who is to the side, how many meters?
190.
190 meters.
190.
Okay. So which one of these guys is going to experience a more concentrated dose of this explosion as far as sound
Whoever's
goes?
closest under 100.
Exactly. And the reason for that is because intensity is equal to power over area.
Oh, okay.
So what's actually happening is that as this firework explodes, it explodes with some power, but that power gets less and less intense as it spreads out over a larger area. So both these guys are experiencing the same power, but at a different distance away. So it's actually spreading out in like a three-dimensional sphere. So by the time it gets to this guy, the sphere has gotten that big, right? By the time it's gotten to this guy, the sphere is much bigger.
Okay, that makes sense.
So when it gets to this guy, the sphere has a radius of 80 meters.
Okay.
When it gets to this guy, we don't know what the radius is yet, but we can figure it out with Pythagorean's theorem. Because we know that this is a right angle right here. So if we want to know the distance between our second observer and the explosion, we can just take a squared plus b squared equals c squared. So 80 squared plus 190 squared
Oh,
equals...
that's, you're good. You're good.
So I got 206.16.
Yeah.
Now here's kind of the black magic part that I don't really understand, but it works. So there's a relationship. Obviously intensity and radius are related to one another because radius is going to be what determines how much area we have in our growing sphere, and intensity is related to area inversely. So what ends up happening somehow, and I can't give you an explanation really, is that I over I naught, so this term right here,
Yeah.
ends up equaling, or at least being proportional to R2 squared, actually let's call it R1, over R2 squared. So R1 squared over R2 squared.
Is R2 just our bigger circle, the one you mentioned earlier?
Yeah, well, our bigger one goes on top. So it all depends on which one. So if we call this observer 1 and this observer 2, then yeah, it would be R2 squared over R1 squared. Yeah, the bigger of the two goes on top.
Is that like a common rule? Is it like just for this exception kind of thing?
Well, I think it would work, it must work every time,
Yeah, it works.
but it's not in the textbook, at least not that I saw. And so
Okay. How'd you get that then?
some other kids said that that's what their teacher told them to use.
Sweet.
So I'm sure that if you played with this relationship enough in regards to this equation, you could somehow figure that out, derive that. But
Okay.
I don't know exactly how. So we won't waste our time trying to play with it.
Gotcha. So our R is just the 206, our R for that two, R2 is just the 206, right?
Yeah, so we end up with 206.16 squared over 80 squared.
Interesting.
That's gonna give us some number. Whatever that number ends up being, we put that here in the parentheses. So we would just
Cool.
take the log of it and then multiply it by 10.
Because that's what we're looking for, right? The intensity?
We're looking for the decibels. So I think the actual question is asking for how many more decibels is this one, or how many more decibels is this guy experiencing than this guy?
Wow, so we're looking for B. That's decibels, right?
Yeah. So we end up with, so we square that. There you go, 80 squared. Take the log. Multiply by 10. So I got 8.22.
For
The final answer.
That beta B is decibels, right? That's what decibels means?
Well, decibels is usually a dB.
So what is that, what are you solving for with beta?
The answer comes out to be in decibels, but yeah, I don't know. Let's see.
I guess my question,
Yeah, so it's beta in decibels.
okay.
Yeah, so I don't know why I don't just say dB equals
Mhm.
10. So yeah, I don't know what beta stands for.
Alright,
Yeah, it ends up being some number of decibels.
that's my next problem. I'm not sure if I'm lining up right, but maybe. So the same problem as us, only they have different numbers, huh?
Yeah, they just had different distances from the explosion.